It takes time to do all that process, you know.
Yes.
It takes time. Yeah. So it is gone live. It takes time to do all that process, you know.
Yes.
It takes time.
Ma'am, send the YouTube link on web discussion.
Yeah. I have admitted Sir in this and so it is gone live.
Hello.
Yes, sir. Yes, sir.
Good morning.
Good morning.
Ma'am, send the YouTube link on web discussion.
Oh, I sent it on chat. How do I send it on? I have admitted Sir in this and so it is gone live.
I think a lot of echo is coming from the mics.
Yes.
Echo.
Sir, now it is okay?
Yeah, now it's better.
Yeah, because my audio was on, sir. Sorry.
Okay, no problem. I'm saying in general.
Isal, I sent it on web discussion.
Okay, ma'am. Okay.
Hello, Neville.
Hello, ma'am. Good morning.
Yeah, when do I press the record button, Neville? Should I press it after the session begins?
Yes, ma'am, at 4 o'clock.
4 o'clock?
11.
11 o'clock. Otherwise, ma'am, the record, this chat will come on live.
Just remind me, otherwise I'll forget.
No, I'll tell you.
Everybody can record actually.
Ah, yes. To me, when do I frequent the
Do we have 5 minutes? I just want to talk something.
Yes,
Yes, sir.
See, during the session, I would like to put some questions which are, and I would like to seek some responses. And I would like to sort of have a kind of chat, audio chat possible. Is it possible with one or two of you?
Yes, sir. So you want the participants to speak, right?
Yeah, but all may not be possible to speak. So I think probably out of the host or co-host, people can. So I don't know who will respond, or anybody can respond, or who will monitor this, who will be speaking.
So I will monitor it. Also,
Okay.
now you will do it or what?
Yes, ma'am, I can do it.
Okay, yesterday you did it well, you can do it. And who will
Yes,
do
ma'am.
the questions today?
Ma'am, Risal will be doing it today.
Okay.
Ma'am, what I do is I take screenshots and I hand it over to Alsona. Like yesterday, I did that.
Okay.
Yes, Neville. Neville, I think you can directly give it to Risal today.
Okay.
Okay, thank you.
See, as soon as I say that this is a question, or
Yes,
I
sir.
would like everybody to write something in their chat, what possibly the answer could be, right?
Yes, sir. Okay.
At that time, I would like to have some audio chatting kind of possible. So who will?
Okay, sir. So do you want me to read what people have written the answer in the chat box?
No, it's like as if one of you is a student in the class and I am asking in the class and somebody wants to answer that question.
Okay, so I think I can do it.
Also, now have you put it in the group, groups, the meeting ID and all?
No, ma'am, not yet. At 10:45, there are still 5 minutes.
So there is somebody waiting with a number like B220 or something. So I think it is a staff member. So should I admit that person?
Yeah, probably my wife might have put in.
Okay, okay.
I don't know that ID is hers or not, but anyway.
Ma'am, also, can you just make us the co-host so that even we can see?
Yes, yes. I can see madam is also there. Ma'am,
Yeah, I'm there. Vinny, good morning.
ma'am, sorry, I just got into this. Yeah.
Yeah, good morning.
Good morning,
Good
ma'am.
morning,
Good
ma'am.
morning, ma'am.
Students also now.
Good morning, ma'am.
Good
Yes.
morning.
Good morning, ma'am.
Morning.
Good morning, sir.
Sir, we
Yeah.
have Dr. Susama Samuel. Ma'am is our principal.
Okay.
And sir is Professor Inder Rana. He's from IIT.
Hello, sir.
Hello. How
Good
are
morning,
you?
sir. I am fine, sir.
Good,
Waiting
good.
for your session, sir.
Good. Let's hope it is as tasty as you thought it should be.
Where is
It will
Neville?
be sure, sir. It will be very good.
Also, no, I can't see Neville.
Ma'am, he is there. I think his video is off, but he is there.
Okay, so sir, Alsona, Neville, and Riesel, you all are co-hosts, huh?
Yes, ma'am.
Yes, ma'am.
So should I start playing the PPT now, if it's okay?
No,
Yes,
so
ma'am.
just one thing more.
And
In between my screen sharing, I will not be showing something, the PPT. I will be doing more talking sometimes. So at that time, I switch on my video or
yes,
myself?
yes, sir. Switch on.
In fact, sir, when you're sharing your screen, that time also you can keep your video on.
No, I don't want all the time on because most of the time it will be audio only required.
Okay, sir, then you can start your video when you want to
Yeah, so
not show anything.
I can
Yeah.
put on my video as and when required, right?
Yes, sir.
Okay. So for example, when I am probably asking questions, I may switch on the video. Even
Okay,
if
sir.
it's not on, don't mind it because the audio questions should be okay. But when I'm saying something which is not on the screen, right, then I would like people to listen to me rather than just staring at the blank screen or something.
Okay, sir. Okay.
So I'll monitor at my end.
Yes, sir. Okay.
Okay, fine.
Experiences.
Can you all see my screen?
Yes, ma'am, we can see.
Who's on YouTube today?
Ma'am, we all will be monitoring on YouTube as well. Ma'am, Kalpana, ma'am.
Yeah, Alsona, please put the links, on the.
Okay, ma'am, I'll put the links.
You can admit, no, Alsona.
Yes, ma'am. Ma'am, so I'm sending the links in the group, so now people will start coming in.
Yeah, but Alsona, it's only 10:45.
Yes, ma'am, we were going to put at 10:45 only.
Okay, okay.
Vinay. Hello.
Yes, sir.
Yes, sir.
I just wanted to ask when the session starts, shall I start or Vinny wants to say something?
Ma'am, so there will be an introduction first, and then you can start.
Okay, fine.
So there's an introduction and then you can start, sir.
Okay, fine.
We will let you know.
Sure.
Ma'am, I think all 100 of them are there in the Zoom room. So now we'll wait for participants on YouTube. Neville, are you there?
Yes, yes, yes.
Can you all just open the chat on WhatsApp groups for participants in case they have any difficulty in joining?
Yeah.
If you are there, even you can enable the chats.
For how long do we want it active?
We'll keep it active till the session ends.
Okay. You have to do it for group 3, yeah? I'm not there in it.
Yes, I did it, Neville.
Done. Also, has someone locked the meeting room?
Yes, I locked it, Neville. You want to open it?
Yes, ma'am, because right now there are 98 participants and someone keeps coming in or, leaving.
Okay.
I got a message from the WhatsApp group 4.
Because it was 100, no, so I did it. Participants are 100. Participants are already 100, you know, so I don't want to admit the more.
It won't come, ma'am.
Pardon?
They won't come.
No, don't admit anybody, Neville, because somebody will be thrown out. Shall we begin also now?
Yes, ma'am. I think we should begin. It's 11.
So can we begin?
Yeah, please.
Good morning, all the participants. Professor Inder Rana, our resource person for this session. Our principal, Dr. Susamma Samuel. My colleagues, some are on YouTube, some are on Zoom. And all dear participants, our student coordinators, Alsona, Neville, and Rizal. Welcome to the second session of the webinar series on strategies and solutions for boosting mathematics learning. Yesterday we had Ms. Zara Parikh, who spoke on augmenting student engagement of elementary and children with special needs in mathematics. Madam stressed on two different strategies, the explicit strategies and the implicit strategies. We had sent you the YouTube link on our very own channel, Mathematics Learning, which is developed to share innovations, to share thoughts. We are really overwhelmed to have 1,084 participants registered for this session. We have different samples or different sections of participants, that is students, student teachers, school teachers, college professors, teacher educators, special educators, remedial educators, and even parents joining our session. We have participants from different parts of the globe, definitely our own very country, India, where we have participants from Maharashtra, Goa, Gujarat, Telangana, Tamil Nadu, Bihar, and around the globe we have participants from Kuwait, Saudi Arabia, Singapore, and UAE. We thank all the participants for joining us on this web series. As we requested yesterday, we want to continue this program as a monthly series to boost mathematics education. So we request from the participants, if you have some resource regarding mathematics education, if you have done some innovation on mathematics education, kindly write to us on the email ID given in the brochure. As a follow-up activity of the two sessions which we had on the 2 days, we request you to subscribe to the Mathematics Learning, the YouTube channel which is created by the Mathematics Pedagogy Unit. We would like you to share a 1-minute video of yourself speaking about some innovation in mathematics or your perception on mathematics teaching learning, which with your permission, we could upload on the YouTube channel. The channel also has a discussion forum. So as you have some good thoughts or some innovative thoughts in this area, kindly share it on the YouTube channel. So with these words, I would like to warmly welcome our resource person, Professor Inder Rana, and I request Ms. Rizal to kindly introduce her and then begin the session. Thank you.
Yes. Good morning, everyone. Ma'am, am I audible?
Yes.
Okay. So welcome to day 2 of this math webinar series. Today, we have with us Professor Inder Kumar Rana to speak on quality improvement in teaching of mathematics. Before sir starts his session, Let me give a quick introduction of the resource person. Professor Inder Rana presently is an Emeritus Fellow at Department of Mathematics, IIT Bombay. Sir has 36 years experience of teaching mathematics to BTech and MSc students at IIT Bombay, and Sir also holds the position of President at AMTI, that is the Association of Mathematics Teachers of India. Professor Rana has supervised 3 PhD students and has authored 4 books, namely Introduction to Measure and Integration, From Numbers to Analysis, Calculus at IITB Concepts and Examples, and last but not the least, From Geometry to Algebra. Sir has also won the following 3 awards. First, C.L. Chandana Mathematics Award given by Saraswati Vishwas Canada for the year 2000 in recognition of distinguished and outstanding contributions to mathematics research and training. Next, the Excellence in Teaching Award for the year 2004 awarded by IIT Bombay based on evaluations by students. And Sir has also bagged the Aryabhatta Award in 2012 from All India Ramanujan Math Club for teaching and working towards math education in India. Professor Rana has also developed interactive web courses for calculus, linear algebra, and measure theory. Sir is presently passionate about mathematics education and therefore has been organizing training programs for school and undergraduate students. Sir has also organized professional development workshops for secondary level school teachers. 7 such workshops have been held touching about 500 teachers. Professor Rana has also organized national level conferences on technology and innovations in math education for 6 times. Sir has also started India Math Education Network, a technological solution for teachers, students, and parents to interact online. Sir, we are privileged to have you with us this morning. Once again, a warm welcome on behalf of St. Xavier's Institute of Education and a kind request to begin your session. Over to you, sir.
Sir, we cannot hear you.
Ma'am, could you please hit the record button?
Yeah.
So let me repeat what I said earlier. Let me thank the organizers, especially Winnie, for asking me to join this session. It's a pleasure to be always talking to teachers and students of mathematics. What I'm going to talk about is something which almost all mathematics teachers and students ask 2 questions. One, why is mathematics so boring? There is a math phobia among students and maybe among some teachers also. And on the other side, there is a question, how do I make it mathematics simple? How do I make it mathematics interesting? And so on. I think these 2 questions are related to each other. I don't know whom to blame. There are many. I can first of all blame the parents themselves. When they send their kids to school, they start telling them, hey, be careful. Mathematics is a difficult subject and you should be very careful in the class. Otherwise, you will be left behind and so on. So even before a person has learned or tried to learn driving, you scare him that the roads ahead of you are full of potholes and there may be accidents and so on. So you already bias your child. Maybe that is because of your own knowledge about mathematics. That is one. Secondly, the possibility is that the curriculum is so designed that it does not take into account that mathematics is to be taught in a particular way, so that students not get afraid of it, they start loving it. That is a possible thing. And third is the persons who communicate between the books and the student, who take the knowledge from students to, to the students, and maybe it's a all individual effort. How do you transact your curriculum in the classroom? So today's talk is going to be something about more like input to teachers, how a particular topic, how a particular lesson for a particular topic can be prepared so that your teaching in the classroom becomes more interesting, students find it more interesting, and hopefully you also start enjoying it. So let me say a few words more before I start sharing my screen and doing something. You see, when you want to serve some food to a particular person, you keep into account many things. What are the food habits of the person, whether the person likes spicy food or salty food or non-oily food or oily food, and whether the food is nutritious and not. While on the other hand, all our education centers around giving same food for all students. A student may like the food, may not like the food. If you like it, the student will take it. If the student doesn't like it, will remain hungry and starts feeling very sad that, oh, I can't understand what mathematics is being taught or what food is being served to me. Right. So I'm going to share some strategies that have worked very well for about 500 teachers in Maharashtra. We did a project. I'm getting some interruptions in between. Some others' iPhones are being shown to me, but it doesn't matter actually. Please restrict yourself
Yes.
to not. Okay. So let me. I don't know where was I. My thought process has gone haywire. Yeah. So it was about the project in Maharashtra government where we trained mathematics teachers, 2 batches of mathematics teachers over 1 year each, on how to improve the quality of math education. And the basic questions that we had in our mind was how to possibly give solutions to the 2 questions that I asked. So I will try to say something about that. So it may be that methodology of teaching in a classroom I would like to share with you today. So let me share my screen.
Hello.
Hello.
Participants, please mute your mics.
Right. So title of my presentation is Quality Improvement in Mathematics Teaching, basically pertaining to the classroom. How the classroom teaching and learning can be made more interesting and made more effective. It is not a research. Okay, quality improvement in mathematics teaching. That is the title of my presentation today. The aim is to give you some inputs that directly you can use in your classroom. So, and hopefully they are very simple and suggestions that should work for you. Let me begin with asking a question. First of all, this is a very nice quote. The mind is not a vessel to be filled, but a fire to be ignited. So teaching should not be taken as taking the knowledge from the books and dumping it in the minds of the students. It's more like igniting a fire in their mind so that they start learning. So there is a difference between the two. So try to understand this quote. And even before that, let me probably, okay, I think let us go ahead. So as I said, teacher is the link between the knowledge and the students, taking the knowledge to the students. And if you know the concept of functions, this is a set, that is a knowledge, and that is a students, that is a set, and here is a function, that is a teacher. So that gives you mathematically a function. Teacher becomes a function from the set knowledge to the student. So here is mathematics entering into the picture in the pedagogy of teaching and learning. So this is a, and if you try to draw the graph of this function, that you can call as the learning curve. So let me not go into that much. So how to make teaching more effective, that is the title of. So there are 3 steps of teaching and learning that I would like to propose. And this is the 3 steps that we have tried in our classroom in various districts in Maharashtra. And all over, there has been a very positive response. And many of the teachers have actually started using this kind of technique in their classroom. So in the 3 steps, one is observe and explore. The second is define and prove. And the third is apply and evaluate. So what is the observe and explore? So this is the step that leads to, that is a step that you should be following in your classroom when you want to introduce a concept. The aim is to develop pedagogical and content skills that are necessary for effective as a mathematics teacher to motivate students, the topic that you are going to touch. So this is even before we have started teaching a particular topic. This comes as a prelude to the topic that you want to teach. Okay. So here is a, how do you do that? Start your lesson with an activity related to the topic. It can be a video, it can be a puzzle, it can be a game, or it can be a hands-on activity. So pick up something that relates to that topic and conduct it. This should, when you are doing that activity, this should motivate you to ask questions and initiate what is called math tap in the classroom. This is a very sad thing that we don't allow our students to talk in the classroom, and more so about the topic they are learning. So this is what is called math talk. Make your classroom more interactive so that you can ask questions, you can get responses of students, and start mathematics, what is called math talk. And there is a lot of research being done. How does math talk help in removing the math phobia and making things more interesting? So try to inculcate math talk while doing that activity. Asking leading questions when you're doing that activity, you can ask some leading questions, solicit students' responses, and discussions should lead. So teacher should be a facilitator leading the discussion to the topic that you want to teach, so that the students feel what they are doing is they are discovering themselves. So the knowledge becomes their own. Somebody writing on my screen, please avoid that. Annotating on my screen, please avoid that, because that will be recorded and there'll be a problem. Okay. So let me come back to my presentation. Okay. Right. Okay, I have lost now mouse. Okay. Right. Second step in this lesson planning is what is called define and prove. Once you have reached the concept through the puzzle, through the game, through the video, to the concept that you want to teach, then you do what you are regular teaching and learning. That is, namely, that step is called define and prove. So this relates to transacting the main part of the curriculum. That is what your curriculum is. So there you will start defining, stating theorems, proving theorems, and so on. Okay, but in this also try to incorporate what is inquiry and discussion. You should ask some questions when you are teaching, and that should lead to discussion. And while proving theorems, instead of just giving a proof, the reasoning and the proof should be incorporated in that thing. And you probably can say something about frequently asked doubts. As a teacher, you are experienced, and you can share what are called frequently asked doubts in that portion. That is define and prove when you're teaching a particular topic. Technological tools should be integrated topic-wise to strengthen the day-to-day teaching. So I'll be giving you some inputs about the technological tools to teach and learn. Okay, in a particular. And the third part of our lesson planning, the third step is apply and evaluate. This relates to we have brought students to a particular concept, motivated them to come to a particular concept. In observe and explore, you have done define and prove, proved certain facts in define and prove, and the next part is relates to applying the concept, whatever they have learned. Is it relevant to, I don't know, something has happened. Something, okay, let me just see. Yeah, I think I clicked the wrong button probably. Okay, observe and explore, define and prove, and this part is apply and evaluate. Okay, so as I said, apply and evaluate should be, you can include some non-routine problems which challenge students' thinking. You can give some real-world applications of the topic being taught. So that will help you to effectively evaluate what is called effective teaching. Whether the lesson that you are transacting is really helping you or not. Right. I don't know, there is something. Okay. Right. Okay, here is good. Okay, fine. Right. So these three steps basically help you to transact your lesson in a nice way, in the way that we have taught our about 500 teachers in Maharashtra. So first was, so here are three steps again. Let me just go back and say observe and explore, define and prove, apply and evaluate. Right? So these three steps of teaching. Observe and explore is reaching the concept. Define and prove is transacting the material in the classroom of curriculum. Apply and evaluate is applications of. So let me give you examples of all this. I'm going to pick up a particular topic from the curriculum of 9th and 10th, and I'm going to give you some illustrations of what I mean by introducing a topic, coming to a topic, coming to a concept using observe and explore. So in observe and explore, Let me show you a video. So watch this video. It should load in a minute. Yes.
So boys, जब खिच-खिच, वंदना और खांसी से कमजोर हुआ आवाज, तब लो नए विक्स 3-in-1. खिच-खिच, वंदना और खांसी. Let's do it, boys. नए विक्स 3-in-1.
So it's a small video. This is actually an ad which nowadays is being aired on TV before most of the programs. If you want, I can play this ad again and then start some discussion. For the discussion, I will lead someone
जब खिच-खिच, वंदना और खांसी से कमजोर हुआ आवाज, तब लो नए विक्स 3-in-1.
some of the people, somebody to respond to my questions.
No, sir.
नए विक्स
We'll ask them to raise their hand.
Okay, so you monitor who will be responding and what will be their response.
Yes, yes, sir.
Okay, so in this video, after showing this video to the students, I would like to ask questions like, what did you see in the video? So responses, please. Some of you, all of you can write in your chat box, what is your response? What is this video about? And one of the co-hosts will allow someone to speak about the video. So please go ahead. We want to hear some responses.
Yes, so participants can put in their answers. Yes, sir. So someone says that 3-in-1, 3 problems, 1 solution. Someone can see array. Someone can see magnification and diminishing.
Good.
Someone is talking about the concept of similarity, that a man becomes extremely small or extremely big. Someone is talking about size, ratio, shape, ascending and descending array, big and small.
Okay. So thank you for the inputs. Let me say some of the responses are very interesting. 3-in-1. One tablet solves 3 problems. That is a good way of interpreting this video. There is somebody saying this is a video where something is magnified and made small, right? And somebody else said something about similarity and ratio and proportions. So you can see the response where something is being magnified and made small. If it is the actual classroom, I will take up that point because somebody saying it is similarity, that means the person already is a teacher, probably knowing probably what is the concept being taught. So I'm keeping in mind that the students for the first time coming across this topic that we are trying to teach. So let us pick up in the classroom the idea that the video shows something is made big and large. So, right. So the person who made this comment, I would like to ask that student a question back again. When something is being magnified and made small, and obviously we all recognize that is the captain of the Indian cricket team, Virat Kohli. So when it is made small, does the smaller image looks like Virat Kohli or not? Does the magnified image looks like Virat Kohli or not? The obvious answers when you look at the video again probably would be yes. It is only the size of the image of Virat Kohli is being made small, but it is Virat Kohli, recognizable. So that should lead to something called shape and size. The shape of the bigger or the smaller objects is same, but the sizes are different, right? So understanding that there is something similar, that is the shape is similar, but the size is different. So this brings out that idea of size and shape. So let us go over to this a bit further. So here is my question now. This is the next question I would like to ask, and all of you can put your inputs in your chat box. There are four pictures shown, 1, 2, 3, and 4. So I'm trying to understand that word similar now. Out of these four, can you say some objects are similar to other? If yes, which ones are similar to what? Or maybe none is similar to anything. So in your chat box, please put this input, answer to this, what you think could be a response to the question that in these four pictures, maybe 1 and 4 are similar, whatever reason may be. 2 and 4 are similar, or 2 and 3 are similar. So put this in your chat box and let the moderator respond back as soon as.
Yes, sir. So some people are saying that they aren't similar. Some are saying that 1 and 3 are similar. Some are saying that 2 and 4 are similar, while there are some people who are also saying that the flowers are similar to each other based on their color.
Good. So let me go ahead with this kind of responses. You see, the idea of asking this question was the word similar is interpreted differently by different persons. So some people said 1 and 3 are similar because both are flowers. Somebody else gave a response that 2 and 4 are similar because both are animals, right? Or 2 and 4 are similar because of the picture color is black and white. 1 and 3 are similar because they are colored pictures. Or 1 and 3 are similar because they are flowers. So you see, the aim is trying to make the students understand that the word similar has yet not been made precise by us. It is only an English word, and that is very subjective, depends on the person who is trying to visualize these things. So let us go ahead a bit and let us look at this activity now. So here 1, 2, 3, and 4, there are 4 flowers given to you. And the question remains the same. Which pictures are similar, which are not, and why not? So try to write this and raise your hand. Moderator will try to give your input to me, 2 or 3, so that I can go ahead.
Yes, sir. So some people have answered that 1, 2, and 3 are pink flowers, so they are similar.
Good.
Some are saying that 1, 2, and 3 are similar because they are pink color flowers.
Yeah.
Some are saying that 2 and 4 are roses, so they are similar.
Yeah.
Some are saying that 1 and 2 are same flower with same leaves, so they are similar.
Okay. So now you see how the word similar is being interpreted by different students is as follows. That 1, 2, and 3 are similar because they are all pink, probably that is somebody said. Somebody said 2 and 4 are similar because both are rose. So he or she is interpreting similar as similar flower, okay, similar family of flowers. Somebody said 1 and 3 are similar, 1 and 2 are similar because the leaves are same, right?
Yes, sir.
Right.
Yes.
So the interpreting similarity as only the characteristic being the leaves, whether they are similar or not. You see that still we have not reached a consensus what is similar. So let me go ahead a bit and try to make it more understandable what we are saying, if possible. So now here are activity 3. Now I'm giving you 4 pictures, 1, 2, 3, and 4. What do you think among these 4 are which are similar, and why? Which are not similar, why not? So again, 2 or 3 responses so that I can go ahead and do something more.
Yes, sir. So some people are saying that all are similar. Some are saying that all sizes are not similar. Then all are similar with different magnifications.
Good. So already people have started making distinction now slowly. You see, from flowers and animals and flowers of the same color, I have come to flowers of the same color now, right? It's the same flower, and people are already trying to understand, trying to make students visually can say that probably 1 and 2 look different because they are similar. If all 4 are similar, if I interpret them as all are hibiscus flowers, but the size of 1 and 2 are different, right? Maybe the proportions are different. This is only a visualization. Maybe all 4 have different sizes, right? So still the word similar has not been crystallized. What is similar? So one can go on this kind of activities. There are some more. So let me skip that. For example, you can have this kind of pictures. So various kind of pictures. See now animals. Now even if, for example, in this you say 1 and 2 are similar, that means you think 1 or 2 are same picture but distorted. In what way it is distorted? In what way it is changed? Can I say that 2 is a magnification of 1? Right? Can I say 3 also is a magnification of 1? Right? If I want to say all 4 are...
Someone's mic is on among the participants. Can you please check if it is off?
Done.
So already, you see, once you reach this stage, you are trying to say that things look similar, right? Their shapes look similar, by sizes maybe are different. So idea of all this exercises was to bring to the forefront the idea that there is something called similar, which should depend on the shape and size. So these things, okay. Now, for example, here is something interesting. Now look at these 4 pictures. 1, 2, 3, and 4, right? All 4 are of the same flower called hibiscus, right? And all seems to be not only same, they are all flowers of the same family, same color, same leaves, they are similar. In fact, all are copies of each other. Why are they copies of each other? You can try to see that 1 or 2 are reflections of each other. Okay, this is a rotation of 3 is a rotation of 1, and 4 also is a rotation of 1. So I wanted to show you this slide, especially because when you are comparing sizes and shapes of objects, something physically that comes in mind is namely physically what you will do is you will rotate objects, you will flip objects, you will translate objects, and that is a dynamic aspect of geometry, which unfortunately we don't teach in our classrooms. We teach geometry as a static subject. That's why it becomes a slightly more dry. When there is movement, things become interesting. So there is a dynamic version of saying that all these 4 are same, basically that 1 is a rotation of the other, or 1 is a reflection of the other, or 1 is translation of the other, right? And that is more also useful in when you go to congruence, so of triangles. But anyway, till now, whatever we have tried to do is try to bring in what is similar. Similar should mean something that is same in shape but different in size. So 2 objects will say are similar. So here is an activity that you can try on a graph paper if you like. On a graph paper, you can take the points A, B, C, D, E, F, G, and H and join it back to A. So that gives you a closed figure A, B, C, D, E, F, G, H, and A. This is a closed figure. It looks like ears of a cat, if you like it, right? So you can draw it on a graph paper. And here is something which is giving you coordinates also. So coordinate geometry practice also comes in this now. So in this activity, take a graph paper, plot the points A, B, C, D, E, F, G, H, and construct the polygon that I just now described. So that is one part. So it will give you some hands-on activity with doing something using coordinate geometry and graph paper. Learning also revising coordinates. Okay. So what is the next thing? Now what you do is double the coordinates of each points. You had A, B, C, D, E, F, G, H, right? Double the coordinates. So earlier it was 2, 0, make it 4, 0, 0, 3 goes to 0, 6. So plot the points with the double the coordinates. Double each one of the coordinates. Once they are doubled, join them and you will get a figure like this. Now let us look at these two figures. These two figures, close figures, look like the same, similar. Both look similar. Only the size is different, right? So I am making the concept of shape and size slightly more firm here now. Now you can, students can see that both these figures, the earlier polygon A, B, C, D, E, F, G, H, A, and this new one with double the coordinates is similar. So only the sizes are different, but both look similar. One looks, the smaller one looks like the ears of a small cat. This looks like the ears of a big cat. Okay, right. Now, if you like, two polygons are similar. Yes, I have already given you the reasons. They look very much similar, right, in the picture, right? You can think of other reasons for giving that. We'll also come to that. Because it is a graph paper, if you want to extend this activity, you can ask them to find out what is the area of these two polygons and compare the areas of these two polygons. So here is a beginning of something. If two polygons are similar, what is the relation between the areas of these polygons? So a prelude to something that you're going to prove in your classroom later on. Okay. So here is, you can record this. Here is something I wanted to introduce that you can add this. You can do this activity. One is on graph paper and pencil. And you can also do it using something called Geogebra. It cannot open cat Geogebra. Okay, I think I'll come to this Geogebra a bit later. The Geogebra is a dynamical geometry. Geogebra is a dynamical geometry software that helps you to do many things, almost everything in geometry and much more in a more dynamical, interesting way. Probably I should do this Geogebra thing. If I can spot cat and let me see if I can spot that because something has happened. My link is not working, but I can still try to see if I can locate that. Oh, that is not there. Okay, let me. I'm sorry. This is my mistake. I should have taken care of this. I checked everything should be working, but seems something missed out. Okay, here is. Let us see if it works. Oh, yes, good. So here is a dynamical geometry software called Geogebra. And this is here you can do geometry virtually on your computer, and in a much more interesting way. Okay, so here is what you can do. So I have plotted these points, okay, as in the problem, and you can see that the area between this. Okay, so let us see whether this is visible or not. Okay. Now, why it is called dynamical geometry software? Because things can be moved. For example, this point K, I can move it anywhere I like. Now, if the point K is here, does this picture looks like similar to the earlier one? We'll say it doesn't look like. Here, this ear of the cat is slightly more straight than this. So this two pictures are not similar. So things can be moved in this dynamical geometry software. We'll have more opportunities of seeing this later. So let me go over to what I'm trying to say. In Observe and Explore, you can also look at, it's a very interesting video, but I think I will be falling short of my time of 1 hour. I will just, you can try to see shadows, how they change. When you, in a dark room, take a torch and take your own hand. As you move the torch or the hand, the size of the pictures, size of the shadows change. Why that happens, one can try to reason it out. Okay, so right. So once that has been done, you come to the concept. So we want to analyze, basically, we want to analyze what is. Can you? Is my video visible to everybody?
So right now we can see your screen.
Okay, I minimize it, but okay. Let me just bring my webcam so that I can toggle between the two. Oh, it's already in use somewhere else. I'll have to exit, I think. I'll have to exit my presentation and come back to presentation. I don't like that. So let me go on audio only without video. Okay.
So it's come, your presentation is come.
No, presentation is on. I wanted presentation not visible, but my video visible. Is my video visible to everybody?
No, sir.
Okay, how do I make it visible if I want to? I can't.
So on Zoom, you have to go, sir. There is a start video button.
On the top, there is a audio.
Yes, you just go there. You will get a panel.
Choose virtual video settings.
So first you have to stop sharing your screen.
No, I don't want to hassle of going back and front. So let me continue.
Okay.
Okay. So here the question is, if you want to define and prove, we already come to the concept that there is something called shape and size of an object that has to be crystallized mathematically. If you look at layman's language, size and shape, size being different but shape being same, what do we call it? So if you want to understand in mathematics, the simplest thing in mathematics, the simplest object in mathematics is, so similar, okay. So these are things what we have done and we will come across in day-to-day life also. We can enlarge things and shrink things in various ways and so on, right? So, but let me come back to what I was trying to say. This is what is called, we want to compare two objects, the size and the shape of two objects which are rectilinear. So means what? Right? So that means the objects, their shape is already defined to me. They are called rectilinear. Right? So if two rectilinear, so let us take a line segment. So let me probably try to draw it on my, annotate it on my screen. So here is one line segment, and here is, sorry, it doesn't look like a straight line. Let me try to draw. Okay, I think there is a draw, there is a straight line, one here and other here. Okay, so forget the earlier one, this one. So let us take to these two line segments. Okay, they are objects which are in geometry. That is the simplest object in geometry that we study, a line segment. This is a line segment and that is another line segment. Are these two line segments similar? That is the question, right? So can you put some responses about this? Are these two line segments similar?
Yes, sir. We are getting responses. So people are replying as no. Some are replying as no. Some are replying as yes.
Okay. So already there is still not clear what does similarity mean. Similarity means the shape of the object is same, of the two objects are same, but their sizes are not same probably. That is what is called similar. If this is a line segment, it is part of a straight line. This also is a line segment, that is a part of a line segment. So these two shapes are same. They have the same shape, namely they are line segments, right? But their sizes are obviously look different. This looks smaller, the first one, this looks bigger. So from here, would you like to say that two line segments are always similar? The simplest object in geometry, line segments, can we say that two line segments are always similar? Yes, because their shape is same, both are rectilinear, but their sizes are different, right? So shape is same, but sizes are different. And that will say that these two objects are similar when, so our trying to define objects being similar when their shape is same, but the sizes are different. The simplest object we have taken is line segments. Okay. Now, what is the next best thing possible you can do? Let us try to see it with some angles. Okay. So can we say, if I draw these two, are these two angles similar? How do I check whether these two angles are similar or not? What is an angle? So that brings us to the concept of what is an angle. To me here, as I have drawn it, it looks like from this point, if you call it as, okay, I want to name these things, so I have to go to draw and okay. So this is A and this is B. I'm writing with my mouse, so my handwriting is coming very bad. So this is D and this is E and this is A. Can I say these two angles are similar? What is an angle? It is made up of something that is captured between two.
Yes, so we have some responses.
Yes.
So angle is union of two rays. When two rays meet at a common point, then we get an angle.
Okay.
And people are saying that yes, the two angles shown on the screen are similar. Union of two rays with common origin.
Yeah. Okay. Now, if you want to say these two angles are similar or not, what you will try to do? Probably you will try to translate this angle here and probably rotate it and then try to see whether the lines match or not, right? So basically angle, definition of angle is where two rays meet, right? Here I can't draw a ray on a paper because I can only draw a segment. So this is a ray and this is another ray, right? So an angle is made up of two rays, which are straight lines in a sense. So, and we have already agreed that two straight lines are always same shape. So this AB is same shape as BC, and same shape as DE, and same shape as EF. But the space captured between them, the angle made by between them may not be same, right? So if you want to say that these are similar, I will have to ensure that this angle, right? Because AB is always similar to DE or BC or EF. What else I can say? So this space between them, to say that they are similar, I'll have to ensure that these two are equal. So that gives me a definition of angles being similar. Two angles are similar when the angles are equal. So that is the definition of similarity of angles. Okay. Now what is the next best possible thing? Next best possible thing in the geometry is trying to study triangles. So here is one triangle. I think probably I should go to Geogebra. This is the right time to go to Geogebra. And here is Geogebra. Good. So I should have deleted my things. So here is deleted. Right. So let me delete those annotations that I made, and I look at. So here is a GeoGebra panel. What I have done is I have drawn two angles here, and I want to see whether these two angles are similar or not. So I will have to, one way is, here is the dynamics of the software and dynamics of geometry coming into picture. I can try to move this angle here. To move that in the software, I'll have to do this. So when I move it, so if I make the vertex of the angle coincide, so not only vertex coincides, the arms also coincide. So these two angles are similar. Okay. The next thing possible in in geometry is a closed figure, which is made up of sides, segments, and the simplest closed figure is nothing but a triangle. So when can we say two triangles are A, B, and C, and A dash, B dash, C dash are given to me? So here is C dash. Two triangles are given to me. Can I say that it is similar? So AB is similar to A dash, B dash, or A1, B1. This one line segment B is also similar to this line segment. This is similar to this. So line segments are similar, but what can I say about the angles in between? If I want to say that these two figures are similar, I should ensure that the angles between these line segments, or if I treat them as rows, as rays, they are same. So how do I ensure that? So that is brought by, I can do that. So here is a way of doing that. I am moving my, okay. So in physically, you will think of lifting the triangle and sliding it, translating it over the triangle. So this angle is equal. So this segment is similar to that segment, and the bigger segment is similar to smaller, and the angles are same. So this angle is same. I can also take it on the other thing. So I can also move it here. So these angles are also equal. And the third one, I can see that these two angles are also equal. So in these two triangles, okay, I can also look at this way. Are these two triangles similar? Yes, because this line segment is similar to this line segment is similar to this line segment is similar to this, and the angles for this is equal to this. But this angle is not equal to this. So here comes the idea of correspondence. If I want to say that two triangles are similar, one triangle is ABC, other triangle is A1, B1, C1 or A dash, B dash, C dash. These two triangles are similar if line segments are always similar, but which angles are similar or not, that I have to verify. So maybe this angle is similar to this, or maybe this angle is similar to this. So in that case, I'll have to rotate this. So that is the idea of correspondence. Two triangles are similar requires a correspondence. And what is the correspondence? ABC has three vertices, A, B, and C. A dash, B dash, C dash has three vertices. A correspondence is a 1-1 onto map. You correspond one vertex of one to another, second vertex of one triangle to some other vertex of the, and third vertex to the third. In that correspondence, the corresponding angles should be equal for the corresponding segments. So that is a very subtle concept where students make mistakes in understanding why a correspondence is required, right? So saying two triangles, the definition of what is two triangles are similar. Two triangles are similar if there is a correspondence between the vertices of one and the vertices of the other, so that the included angles are equal. That is what is required. That's all. That is the definition. That is what is required. And once that definition is made, then you prove various theorems that two triangles are similar. Then you prove that their sides are in a particular ratio. And conversely, if the sides are in a particular ratio, then the angles are also equal. So equiangular is similar and the sides are in proportional. Those are all theorems which you prove in your textbook, and you will do it in the classroom. But all those theorems, if you do it with the Geogebra, you will be very happy because the students will see the geometry of it. So one is in similarity, there is a correspondence, that is a map, 1-1 map from the three vertices of one to the three vertices of other. And then there are transformations called dilations and rotations. This is very, this is an activity which I had done in my childhood. I wanted to be a painter, but I could not. So then somebody told me this is a very good way of making a drawing of your picture when the computer softwares were not there. Given this picture, here is the picture of a small wolf, okay? And if you want to magnify it, what you do is draw small squares, right? And then draw a bigger, if this is 3 and you want to enlarge it 3 times or 4 times, a bigger proportional rectangle, and draw those many squares inside as the original one. And then you draw this small ear, so then you draw this small ear kind of thing, right? And then this curve going here, and you draw this curve in this. So that way it will give you an enlargement of, and this can be done in Geogebra very nicely. And same translation and reflections can be done in Geogebra. So these are the dynamic versions of
grade 1 का मैं अग्रवाल का लिस्ट भेजती हूँ अभी चाहिए तो.
So here are dilations and rotations. Dilation is expanding and shrinking. Rotations, we know what is rotation. Translation is moving around, and reflection is like reflection in a mirror. These are very important geometric transformations which are useful, which are used in geometry, in similarity, as well as in transformations are used in congruence. And they play an important role later on when students want to study what are called linear algebras. So I'll not go into that. So we have defined what is similarity and okay. Right. I think I picked up a wrong presentation. I'll have to go back and pick up. In the meantime, you can think of writing some questions in the chat box, which we'll try to answer. And let me locate the presentation that I actually wanted to make. There is a part of it here, which I wanted to use something bigger actually. Okay. The remaining part of my presentation is, I think, here. And let me see what it is. No. Oh, that is also there. Okay. I think there is a slight issue. Let me. Yeah. Okay. Let me just give me a minute. In the meantime, please write your questions. I'll have to leave the presentation, stop screen presentation for a minute. My video is on the screen. That doesn't matter. You can look at my picture in the meantime.
Yes.
That is also a problem. Okay, is my presentation visible?
No, sir.
Okay, I'll share it again. I think I have not shared it. So where do I? Okay, share screen.
Yes, sir.
Yeah, is it okay?
Yes, yes, sir.
Okay. So now we have I have given you some inputs regarding observe and explore, how to get to a concept, define and prove, how to prove various things, define and prove. You're transacting your material. That I have not done much because that is your textbook anyway. And I want to say share something about apply and evaluate. Let me also say something about in your textbooks, on your curriculum, you only deal with the similarity of triangles. One can ask a question, when do I say to rectangles next four-sided figure closed? When do I say a rectangle is two rectangles are similar? Okay. Can I say two rectangles are similar? When do I say it? What is the definition of two rectangles being similar? When are two pentagons similar? When is a hexagon, two hexagons similar? We saw that example of two cats, the ears of two cats, one smaller, one bigger. We said they would look similar. Yes, they were similar, right? So what makes them this kind of a thing, right? So what could be a proper definition of saying a closed figure? Has it to be closed? Or any figure in one, two figures are similar? That is a very interesting question to answer, because we can try to answer very nicely what is similarity for figures which are rectilinear, line segments, angles, triangles. We can also do it without much difficulty. Say two rectangles. We will say two rectangles are similar because they have the same shape, right? Only the sizes. What are the sizes of the sides? The two parallel sides are equal, pairs of sides. If they are proportional, then we'll say that these two rectangles are similar. So we can define for that. Similarly, we can define two, say, hexagons, all closed hexagons, all internal angles are equal. And if the sides are proportional, then they will be similar. Now that's a nice thing to do in GeoGebra. You can probably let me quickly do it for you to help you understand that GeoGebra is not difficult. Okay, so let me remove axis. Let me remove grid. I don't need it. So let me. What I am doing is may not be to all. Okay. Why I'm doing this, you'll just now see it. So let me make what I was trying to say, a regular polygon. I don't want that. I want to do okay. So let me draw a point first, and then draw a segment. No. I think I'm probably. I hope I'm not wasting too much of a time. Segment of a given length, B. So it gives me a segment of a given length B, and are you able to see my screen sharing?
Yes, sir.
GeoGebra is visible, na?
Yes, yes, sir.
Okay, okay, fine. I was just worried that you shouldn't be seeing my face. Okay, AB. So I was trying to do a. Okay, let me regular reflect. Okay, and I want another slider. So a slider here. And okay. I'll just explain in a minute what I am doing. Okay, so I want a regular polygon. Offside. Yeah. Now I am done. What I am doing is, see, I am constructing a regular polygon. So it is this number. I should have made it an integer. So let me number properties. Number property. See, as I move the slider, you can see, so this is the 15 gone and so on. Okay. So in GeoGebra, you can do such kind of things. I have constructed a polygon, a regular polygon with side as equal to B. Okay. If I change this, you see the size of the polygon changes. Right. and this is the number of sides. They become more or less. So let us take a regular polygon. Okay, so this is a regular polygon of side as b is 1.6. So we know all the internal angles of this polygon, same as if I draw another one, right? So what will be the ratio of right? So what will be the ratio of this polygon with the other one? For that, I can draw another one. Okay. So let me, to make it really interesting, so let me okay, segment. And let us draw another regular. Okay, so I think we are in a good shape now. Now you see, if I this is the indicator of the sides. If the things are not visible, let me make it slightly bigger. Font size 20. Yes, it should be okay. So here is. Now you see, can I say this polygon 1 and polygon 2 are similar? Well, I can do that. So what we'll have to do is I'll have to check the angles. So one can check what are the angles of this. So I can see here, internal angle is 128, and here is the internal angle is. The internal angles are both are same. So these are regular polygons. So internal angles, here is this, here is this. So all the internal angles are equal, right? So if I can say that the ratio of the sides are proportional, then I'll be happy. And if you see it, this segment F1, there is F1 on, come on the left side here of the panel, F1 is 3.2 and G1 is 1.6. So the side here is 1.6 and this is 3.2. So the ratio is 3.2. Okay. So the sides are proportional and the angles are equal. So these two hexagons are similar. Okay. So let us increase. You see, this is what is dynamic geometry software. I can increase the number of sides. Okay. So angles remain equal. Internal angles are equal for both, and the sides are proportional. So I can say this polygon 1 is similar to the polygon 2. And here is an interesting question I would like to ask. When will you say two circles are similar? So please give an answer to the question, when are two circles similar? Yeah, so inputs please.
Yes, so participants can put their answers in chat section.
Yeah, so some responses. When are two circles similar?
Yes, sir, we have got some responses.
Yes.
So circles are always similar. Circles are similar when the radius is same, when the radii are in proportion. These are the few responses that we got.
So somebody says circle are always similar. The person is confusing that the shape of two circles, right?
Yes, sir.
Two circles are similar because they are circular.
Yes.
But so let me draw two circles here. Okay. So here is a a circle with center and radius is B, and so here is the other one. Okay, so let me move it slightly. Can I say here is interesting thing I can do. I can object properties and give it red. Okay, and style slightly bigger. This color green and style. So can you say that this red circle is similar to the green circle? I think even somebody who does not know mathematics will say that these two are similar. Yes, looks like they are all circular. This is also a circle. So those two are similar, right? So two circles are always similar, like two segments. They're always similar, right? Only thing is, if they are similar, then radii will have some relation, right? Radius of this one will be radius of some constant multiple of radius of this one. Now, can you think why do we say that two circles are always similar? Can we deduce it from the polygons? Is there any relation between the polygons and the circle? So that is a question. Probably, I think, does anybody have an answer to this, or want to venture why? How do you get that two circles are always similar, right? Because the shapes are same.
Yes, sir. One of the participants has also responded as
Yes.
sum of angles.
Angles of?
Sum of angles in polygon.
Mm-hmm. How much is the sum of the angles in the polygon? It is?
Angles of circle are 360, complete 360 degree.
Yeah, that is interesting. You see, you think of circle as a regular polygon with how many internal angles? There is no concept of internal angles of a circle. So the way of visualizing that is, for a circle, what are the characteristics? A circle is determined by the shape of this. It is a locus of all the points at a particular distance, right? So it is a distance of this from any point on the locus that matters. So any two will be similar. Another way of looking that would be, if you look at two polygons, as you keep on increasing the number of sides, it becomes a circle. So let me show you that. After some stage, you will not be able to visualize it. So let me increase. From 10, I am increasing. Oh, it's going very big. Maybe let me probably shrink it a bit. Zoom out. Okay. Let me move it here, and let us move these objects. Okay. They are overlapping, but I can't help it. Now you see, as increase the number of sides, what is happening to n-gons? When the number becomes much large, they almost tend to become circles. So the idea is, as the number of sides increase, a polygon n-gon tends to become a circle. So internal angles become equal. It's only the side, the distance from the center of it, which depends upon the side actually, right? That become equal. See, for a n-gon, the center to the point. Okay, that distance depends on the side of it, so one can. Okay, so I just wanted to say that if you like in your classroom, you can extend the idea of triangles being similar to polygons being similar, and then say what could be the definition of circles being similar, right? In general, the idea of two figures being similar is more complicated. That requires more discussion. So here is something about apply and evaluate. Do these things have any applications? Yes, a lot of it. So what is it we are doing? We are looking at similarity of objects. So this you must have done in your classroom, so I won't spend time on it. That if you want to find out the height of a flag post, you can do it by measuring shadows. You try to put a stick. Supposing sun is somewhere on the top, on the right side, the light rays are coming. Light rays hits at B and then it gives a shadow. So AC is the shadow of the pole. You can try to put a stick in between, ED, so that the shadow of the stick matches, the top matches with C. So once you do that, then you understand that these two triangles CED and BCA are similar. So the sides must be in proportional. So if you can measure CD and measure CA and take the ratio, that should be same as the ratio of ED and BA. So if you know ED, you can calculate BA. Okay. That is a standard example given in textbooks also. So you can do that. Here is something which is not probably given in textbooks. Measuring, suppose you want to measure the height of Qutub Minar. So if you want to measure the height of Qutub Minar, then you can't look at the shadows and such things. So an easier way would be put a mirror here somewhere, a bit far away from, okay. Once you put a mirror.
Hello, sir.
Yeah.
Sir, we need to wind up in few minutes, around 5 minutes or so.
Okay, I'll wind up. I won't do our other applications. So this is probably not given, so I will do that. So this, put a mirror so that while standing, you can see the top of the Qutub Minar. So light rays going here and light rays coming and hitting here, right, to your eye, so you can see the top. And that should tell you from physics, the angle of incidence is equal to angle of reflection. So that should help you to prove that these two triangles are similar. And if you know the height of AD, you can calculate the height of the Qutub Minar once you know what is the distance AC and what is the distance BC. So these are applications, and all this can be done in GeoGebra. They can be very well done in GeoGebra to make things interesting for students. So these are useful in making maps. Okay, there are problems in shadows. Probably I'll just here is okay. Here is a problem which you can try. A man is standing on a road, and there are lamps on both sides. From this lamppost, the shadow falls at the base of this lamppost, and from the lamppost from the right side, left side, the shadow of the man falls at the base of this. Suppose that is given to you. Okay, and suppose you are given what are the heights R1 and R2 of the lamps. This R1 and R2 are given, and the height of the man is say R. So what is the relation between these three heights? Height of the man, height of the lamppost R1, and height of the lamppost R2. So what are the relations between these three heights? You can try to solve later on and try to interact. Okay, the man's height is R. So what is the relation between these? Okay, so let me wind up this session by recalling what I have done. I have tried to give you input on how to go about planning your classrooms. You should divide it into three parts. First part should be observe and explore. where you should do something. You see, showing a video, doing a puzzle catches the attention of the students, right? It tells the students you are going to do something interesting. You are not going to repeat what is in the classroom, what is in the curriculum written down there, right? And that will also help them slowly to come to the concept. So observe and explore, bring to the concept, define and prove, do what your classroom curriculum says, and apply and evaluate. Give them something that helps them to understand that the classroom mathematics they are doing is actually related to the outward world also. So there is a relation between the two. Okay, classroom mathematics is not for exams. It is also for exams and also for solving real world problems. So that you should do. And all along, try to bring in what is classroom interaction, what is math talk and such things, right? So let me stop here and come to something which is observe and about question answers if we want to do something. So let me stop here, and in case there are some 2 or 3 questions, I don't mind even taking 5 questions, but I think this time is already up. So you want to put some questions?
Yes, sir.
Yeah.
Yes,
Over
sir.
to Archana. Yeah.
Yes, sir. Thank you for that effective input. Now there are some questions from participants on Zoom and YouTube, both that I would be asking you. And the first question is as follows. While teaching students in the age group of 10 to 15 years, I have noticed that children do not want to go creative or aren't curious enough to want to solve non-routine questions. How to build up on it?
Here the problem lies with the parents or our education system. All our education system is geared towards examination and doing well in examination. And our examination system asks only repeated skill-based questions, does not ask concept-based questions, right? So unless the student feels the need to do concept-based questions, right, they will not be interested. So this is a big challenge. I agree that how to make students understand that what they are doing is concept-based. Okay, it is activity-based. They have to do something to understand something. It is not just solving problems, right? 2 plus 2 is 4, but why it is 4, that they have to understand. And that is the problem, lacuna with our education system. Our education system has not till now come to a stage, evolved out of a stage where we can evaluate creative questions, promote independent thinking. Our even curriculum does not put some questions in the textbook for those students who want to build their intuition, right? So I says a teacher can pick up some good students, good in the sense who are interested in these kind of things, and maybe hold some extra classes once in a while, once in a week, once in a month, as and when they want it, kind of a thing, as and when you can do it. So responsibility lies on the teacher till it is forced by the curriculum to do questions which are creative and independent thinking.
Yes, sir. Thank you. Next question is, like we have GeoGebra for geometry, is there any tool to teach algebra?
I should have said that GeoGebra is a combination of geometry, first 3 letters GEO, and last 3 letters of algebra, Gebra, GBRA. So not only it helps you to understand many things, almost everything in geometry, it helps you to understand a lot of things in algebra. Okay, not everything, of course, because algebra is more symbolic based kind of computing, but it helps you to understand many things in algebra. You will have to learn GeoGebra, and on the GeoGebra there is a what is called algebra panel. So I think there is, for example, on the left side. Oh, I am not sharing my screen, so I can't show you that. So when you open GeoGebra, there is on the left side whatever algebra you are doing, on the geometry panel that is visible as a algebra on the algebra panel also. So a lot of algebra can be done. And you will be surprised now you can do a lot of statistics. You can do a lot of 3D geometry using GeoGebra. So explore GeoGebra.
Yes, sir. Thank you. Thank you for answering all questions so patiently. I just have one last question for you, sir. Can you suggest some strategies to reduce math anxiety in classroom?
Remove exams. If there are no exams, there won't be any stress on anyone. There won't be any exam. See, now at present, what is happening is every month there is a unit test, or every week there is a unit test. The student is always worried about performing in a unit test, performing in a tri-semester, performing in a middle school, mid-year, performing in annual and other kind of things. Exam is inversely proportional to understanding. If there are more exams, there will be less understanding. That is my theorem. And almost every teacher will agree to it. And I think because there are no as such formal exams till 5th standard, and they know that probably in many states they will be promoted. I think there's more incentive for teachers to do some creative teaching and learning, at least up to 5th. And once the students enjoy creative teaching and learning, once you do 6th standard onwards, they will ask you, "Madam, वैसे ही करिए ना जैसे प्राइमरी में करते थे, वैसे ही सिखाइए." So they will catch you. So
yes,
do that till our assessment system, till our book writing improves, there is hardly any scope of improvement. It all depends on parents and teachers. Innovative teachers can innovate rather than just linearly transacting curriculum from the book to the classroom. Don't
yes,
do
sir.
that.
Thank you so much. Yes, sir. Thank you so much for answering. We have lot many questions, but participant, as you see, due to time constraint, we are not able to take up all questions. But yes, you can reach out to sir on the mail that will be provided on the WhatsApp group after this session. So
Anyway,
that's
my
it for the.
simple email to remember is IKRana, IKRANA. That is my name. Initials, small letters, one word, ikrana@gmail. So you won't forget.
Okay.
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 And
Thank you,
thank you
sir.
very much for being part of this session. Uh, your contribution to my would be your questions, your inputs. What would you have liked to see? Or what answers you would like? If you send me some inputs like that, that will help me to do a better job next time. I can help you better next time. Thank you very much. And thank you, organizers.
That's it for the Q&A session. Over to you, Winnie ma'am.
Okay, I would request Dr. Susama Samuel, our principal, to say a few words now.
Okay. Thank you, Vinny.
Yes, ma'am.
Now we have come to the end of today's webinar on strategies and solutions for boosting mathematics learning. This webinar was meant for the students and the teachers of all levels from primary to higher education. And I think it was a very useful session for the parents also. And next time we should see to it that parents should be compulsory participating in this webinar, because it was helpful for the parents also. And the purpose of this two-day webinar was to discuss the quality of mathematics education. And yesterday, for the first session, we had Ms. Sarah Perek spoke on how to engage students in class through various interesting strategies, and how a mathematics teacher should provide learning experiences through real life situations so that learning becomes natural to them. And today, Professor Rana sir also spoke on the same line, how to improve the quality of mathematics teaching and mathematics learning. And sir has shared lots of his expertise with us on how to develop interest in class through maths talk, maths activities, and also how to remove that the phobia, maths phobia from the students' mind. So both the sessions were very informative, and in the coming sessions and in the web series, I think we will discuss various factors to improve the quality of mathematics education from different dimensions. So this initiative was conceived and conceptualized by Dr. Vinnie Sebastian, Associate Professor, and her Mathematics Pedagogy Unit. So Dr. Vinnie, a well-planned and well-conducted session. And so congratulations to you and your team and the students. I'm not taking the name of the students, but all the students who put inputs to this. So congratulations to all of them. So on behalf of St. Xavier's Institute of Education, I express my appreciation as well as a big thank you to you and your team. So all the best for the coming sessions, the web series, what we are planning. Good luck. And I thank both the resource persons, Ms. Parekh and also Rana sir, for these interesting and informative sessions. I thank all participants, our faculty members, our colleagues, and the students, those who have participated in this session. Thank you very much, and over to Dr. Vinnie.
I think you can wind up. It's okay. So without much delay, in case Vinnie wants to say something.
Yes, sir. We have one of our participants who wants to share her reactions to this webinar. So she, unfortunately, she couldn't come in YouTube, in the Zoom, but now she is just coming in and she will be just sharing her reactions to the webinar. So can we just wait for a minute? She's just coming in.
Okay. वीडियो बंद कर दो वीडियो भी बंद है वीडियो भी बंद है
Got in? It is blocking. No, it is open actually. Oh, I already announced. No, come. I have disabled the waiting room also. Okay, in the meantime, I would just remind the participants about the feedback form, which is going to be posted on the WhatsApp link. Please fill the feedback form, and maybe we'll take some time to enable the certificates for those who have attended both the days. We would also request you to send the 1-minute video of your perceptions of mathematics education, and we would love to upload it on the YouTube channel. We also request you, if you are a resource person or if you want to speak up on innovations which you have done in mathematics, please write to us on the email ID which is given in the brochure, so that we can have we can continue this journey which we have started. We want to see that there is some difference made in this area of teaching learning, and we want to contribute a lot to society. So I would love to have all of you on this platform and journeying with us towards our objective. So Rashida ma'am, are you in?
Yes, I'm here, Vinny.
Yes, so we welcome Dr. Rashida Kapadia, who will be speaking for a few minutes on her impressions about the webinar. Yes, Dr. Rashida, can we see you?
Yes, there's somebody already speaking. Okay.
So Rashida ma'am, are you in?
Yes, I'm there, Vinny. Is my audio?
Rashida, you have to mute your YouTube. If you are on YouTube also, mute that.
Yeah, I'll do that.
There's somebody already speaking.
Okay, can you hear me now, Vinny?
Yes, ma'am, we can hear you.
We can hear you. We can.
Okay. A very good afternoon to all. Respected Father Blaze, respected Principal Dr. Sosama Samuel, Dr. Vinny Sebastian, our guest speaker, Dr. Inder Rana, and all the participants. I'm so glad to be speaking at the SXIE platform once again. Sorry, I'm not able to start my video for some reason, as you know, Dr. Vinny has already said. It's a last minute this thing. I couldn't join initially earlier. Definitely this was a very informative session. Yesterday's session and today's session both were very well planned, giving us an insight into details about how elementary education and higher education can be considered for maths. And especially Dr. Inder Rana, we thank you, can't thank you enough actually, because you gave us a lot of examples that will help us a lot in your use, that we can use in our classes. So I am just too glad that what St. Xavier's Institute of Education, the Mathematics Pedagogy Unit is doing, reaching out to teachers and teacher educators for making maths, more enjoyable. So kudos to the group, the student team as well, and we hope to continue interacting and get being a participant to such more interesting series. Thank you all, and big thanks to St. Xavier's Institute of Education for having organized this.
Thank you, Rachida ma'am. Over to Alsona. Alsona?
Yes, ma'am. Okay. So on behalf of St. Xavier's Institute of Education Manager, Father Blaise D'Souza, Principal Dr. Sosama Samuel, and Mathematics Pedagogy Staff in Charge, Dr. Vinny Sebastian, I would like to extend a hearty vote of thanks to our speaker, Professor Inder Rana, who has enlightened us all with an amazing session today. Thank you, sir, for accepting our invitation readily for this webinar. We are really grateful to you for sharing your knowledge with us. I am sure that all our participants today have gained some amazing insights on how we can improve teaching. Elaborating on 3 steps of teaching based on your experience in various districts of Maharashtra. Through your session, you have also helped us all develop the pedagogical and content skills that are necessary for effectiveness as a mathematics teacher. You have also shown us actual demonstration on Geogebra, which I am sure every participant will agree as an excellent hands-on experience. So thank you once again, sir. We couldn't have asked for a more better resource person. Next, I would also like to thank our dear manager, Father Blaise, and Principal Dr. Sosama for allowing us to organize this math webinar. I would especially like to thank our staff in charge, Dr. Vinny Sebastian, for coming up with this wonderful idea of having an online math webinar in current COVID situation. Thank you, ma'am, for your support. Thank you to our student coordinators, Neville Sharma, Riesel Gonsalves, and Clarice Lemos for being the strong team behind the curtain and providing technical support. As organizers, we were not expecting to have 1,000 plus registrations, and arranging an online platform for such a large audience was made successful by the hard work put in by each and everyone. And last but not the least, a big thank you to all the participants for your presence. Without each and every one of you on Zoom and YouTube, this event wouldn't be successful, and we hope that you are taking back something with you from these 2-day sessions that you will make use of in your respective field. So thank you for making this event successful with your enthusiastic participation. And with this, I will end my vote of thanks.
Thank you, everyone. Thank you, sir.
Okay. Welcome. My pleasure. Okay.
Thank you, sir.
Everybody take care. Safe home back. You are already at home, so be safe.
Thank you, sir.
Yes, sir. Thank you, sir.
Thank you, sir. Thank you very much.
Thank you, ma'am.
Thank you.
Okay, Vinny, bye. Take care.
Bye.
Thank
Bye.
you very much.
Who was that?
Ma'am, this is Annette here.
Oh, hi, Annette. How are you?
Good, good, good. Nice initiative taken, ma'am.
Thanks,
Please
Annette.
have more of this. Please have more of this.
Yes, we are planning.
Okay. So be sure of having me there.
Okay, okay. We will definitely.
Yeah. Thank you, ma'am. Bye.
Bye.
Ma'am, we leave the meeting room now.
Yes, yes.
Thank you, ma'am, for everything.
Thank you, Neville.